Hi, in this video I will teach you the CYK algorithm, which is a membership algorithm. First, let's see what a membership algorithm is. G is a grammar that's given to us. W is a string of terminal symbols. Now, a membership algorithm helps us to determine whether W is a part of the language generated by the grammar G. Now, one such algorithm is the CYK algorithm. This is for context free grammars, and it only works when the context free grammar is in Chomsky normal form. It was named after these three people. Moving on to the algorithm, the first step is to construct a triangular table where each row corresponds to one length of the substring. So, say the length of our string is 4. Our triangular table will have 4 rows and 4 columns. Now let us name the cells of the table. This is x of 1 comma 1, x of 2 comma 2, 3 comma 3, 4 comma 4. Vertical it will be 1 comma 2, 1 comma 3, and so on. Now we have a word of length 4. Say it is a1, a2, a3 and a4. We'll make a table as shown earlier, and we'll write these 4 terminal symbols at the bottom. Now the best way to fill this table is to fill the bottommost row first and then move up, filling the table row wise. So at any point of time, whichever cell you're filling, you'll have all the values below it already filled up. To fill in the values in the table, you're supposed to use this formula. It is a bit complicated, but there is a shortcut. Suppose we want to find out this value. We will take two paths, one coming from the bottommost cell vertically upwards and the second one going downwards diagonally. Now what we do is we multiply the first values on both the paths and take a union with the product of the second values, take a union with the product of the third values, and so on. Suppose we want to find out this value, this value. So now again we'll take two paths, one coming vertically upwards and one going diagonally downwards. Here we'll multiply this value with this value, union this value multiplied by this value, union this value multiplied by this value. This will get clearer as we solve an example. Here we have a question. G is the given grammar. S tends to AB, A tends to BB or A, B tends to AB or B. And the word given to us is double A, double B, A. We have to find out if W belongs to the language generated by G. Now here we have the length of W as 5. So we'll make a triangular table with 5 rows and 5 columns. First of all, we write down the word below the table, AA, BB, A. Next, we fill the bottommost row of the table. Now we check the productions. We get small a from capital A, so we write that down over here. Again capital A. Now small b we get from capital B, so we write B, B, and this is capital A. Now we have to fill the second row from the bottom. So x of 1 comma 2, which is this cell, it's equal to the product of these two, A into A. Now we check the productions. AA is not there on the right side anywhere, so this will be 5. For the next one, x of 2 comma 3 equals AB. AB is there in S as well as B, so we write S comma B, write that in the table. S comma B. Now the next value x of 3 comma 4 equals BB. Now we check the productions. We get BB from capital A, so we write A and we write it in the table. And the next value x of 4 comma 5 equals BA, which is not there anywhere on the right in the productions, so we write 5 and we update the table. Okay, next we calculate this value, which is x of 1 comma 3. Now here's the tricky part. Like I mentioned before, we take two paths, one from A to 5 and the second one from SB to B diagonally. We multiply A with SB and take a union, multiply 5 with B, so that's 5, and this is equal to SAS comma AB. Now we check the productions. AS is not there anywhere on the right. AB is there in S as well as B. We update the table SB. Next we calculate this value. Here the two paths will be from A to SB and from A to B. The first value A into A, x of 2 comma 4 equals A into A union. Then we multiply SB with B, so that's SB union BB. This is equal to AA is not there in the productions, SB is also not there, BB is there, it's A tends to BB, so we write A and then we update the table. Now the next value x of 3 comma 5 equals B into 5, which is 5 union A into A, which is double A. Now this is equal to double A is not there anywhere in the productions, hence 5. Coming on to the next row, x of 1 comma 4 equals, now again we take two paths. This is the first path and this diagonal path is the second one, so we'll write x of 1 comma 4 equals A into A union 5 into A, which is 5 union SB into B, which is SB and BB. So this is equal to double A is not there, SB is not there, BB is there in A, so A and x of, we update the table here. Now next value x of 2 comma 5, this one is, again we take two parts, A from here to here and from here to here, so A into 5, which is 5 union SB into 5, which is again 5 union A into A, which is double A. Now double A is not there anywhere in the production, so this value is 5. Update the table. Now the next value to be calculated is x of 1 comma 5, which is the topmost value. Here we take two paths, one vertical and one diagonal. We multiply the first values, so that's A into 5, which is 5 union 5 into 5, again 5, SB into 5 is also 5, and A into A is double A, so we write that down. which is equal to 5 because AA is not present anywhere. Now here we don't have S in the topmost cell, hence we can conclude that W does not belong to L of G. Now here's another example. In this case the word actually does belong to the language generated by G. I'll just generate it once and show to you how. uh, let's take S. We substitute it with AB. Now we substitute A with BA, so we get BAB. Now we substitute the second B with CC, so we get BACC. And now we substitute each non-terminal symbol with a terminal symbol, so we get BAAA. So now let's see what the CYK algorithm gives us. Of course, now you know how to implement the CYK algorithm, so I don't think narration will be necessary. So in this example we did get S, which is the start symbol in the topmost cell of the table. So we can conclude that W belongs to L of G, where G is the given grammar. Thanks for watching.